Let's say we have a saturated solution of calcium fluoride in equilibrium with solid calcium fluoride. So in our beaker, here's some solid calcium fluoride, which is a slightly soluble ionic compound. And in solution, right, we have a saturated solution consisting of calcium 2+ and fluoride anions. Now let's say we add some acid, right? So we add a source of protons to our beaker, and we observe what happens. Well, we would see some of our calcium fluoride dissolve, and let's say we add enough acid to completely dissolve our calcium fluoride. So what happened here? We added acid, right? We added H+, therefore we decreased the pH, and we saw our calcium fluoride dissolve. So we increased the solubility, right? We increased the solubility of our slightly soluble compound calcium fluoride. So let's see if we can figure out what happened. Right, if we're adding H+, right, we know we have H2O present, so H+ and H2O give us H3O+. So we have hydronium ions in solution, and we also have fluoride ions in solution. And fluoride can function as a base. Right, so the fluoride anions are going to function as a base, and hydronium functions as an acid. If we have 2 fluoride anions, we would need 2 hydronium ions. So hydronium acts as an acid, it donates a proton, and the fluoride anion acts as a base, it accepts a proton. So we make HF, right? We would make 2HF here. And if H3O+ donates a proton, we would also have 2 waters, right? So we would make 2H2O here as well. So let's think about what we're doing to the concentration of fluoride ions in solution. The fluoride ions are reacting, so therefore we're decreasing the concentration of fluoride ions in solution. And remember Le Chatelier's principle, a system disturbed from equilibrium will shift its equilibrium to relieve the applied stress. So here, the stress is decreased concentration of one of our products. Our equilibrium shifts to make more of our product. And so therefore, more calcium fluoride dissolves, and we've increased the solubility of calcium fluoride. We could even write the overall reaction for what's going on here. So the net reaction, right? We can see that we have 2 fluoride anions on the reactant side. We also have 2 fluoride anions on the product side. So now we could just take these 2 and say those are our reactants. So we have calcium fluoride, right, plus 2 hydronium, plus 2H3O+. And we would get for our products, we would get these guys over here. We would get Ca2+, so calcium ions. We would make 2HF, right, so a solution, and also water. Right, so this is another way to think about what's happening. If you add acid to calcium fluoride, you're going to get this for your products. So adding protons, adding acid, or decreasing the pH increase the solubility of this slightly soluble compound, but this isn't always true. It depends on what compound you're talking about. For example, for silver chloride, right, this is another slightly soluble compound, but adding acid does not affect the solubility of silver chloride. And let's think about why. If you add acid, you're increasing the concentration of hydronium ions in solution. And what happened above was the fluoride anions reacted with the hydronium ions to shift the equilibrium. Right, but here the chloride anion won't react with hydronium, and that's because the chloride anion is a much weaker base than the fluoride anion. So let's think about that. Up here, the fluoride anion, if you think about HF, right, the conjugate base is F-. Down here, for the chloride anion, it'd be HCl, with the conjugate base being Cl-. The stronger the acid, the weaker the conjugate base. So HCl is a strong acid, right? A much stronger acid than HF, and therefore Cl-, the conjugate base, is much weaker. So the chloride anion is a weaker base than the fluoride anion, and so the chloride anion isn't going to react with hydronium, and therefore we're not decreasing the concentration of one of our products, and so our equilibrium doesn't shift, and the solubility of silver chloride is unaffected by by the addition of an acid. So decreasing the pH for silver chloride won't increase the solubility. So you need to think about if the base is strong enough to react with the acid that you're adding.